Earth's climate and weather. The Sun is an almost perfect sphere, with a difference of just 10 kilometers in diameter between the poles and the equator. The average radius of the Sun is 695,508 kilometers, of which 20 to 25% is the core, and the Sun is mostly hydrogen and helium. If you could take apart the Sun and pile up its different elements, you'd find that 74% of its mass comes from hydrogen, with 24% from helium. The remaining 2% includes trace amounts of iron, nickel, oxygen, and all the other elements we have in the solar system. In other words, the solar system is mostly made of hydrogen. The Sun is the solar system. We live on the planet, so we think it's an equal member of the solar system, but that couldn't be further from the truth. The reality is that the mass of the Sun accounts for 99.8% of the mass of the solar system, and most of the final 0.2% comes from Jupiter. So the mass of the Earth is a fraction of the mass of the solar system. Really, we barely exist. The Sun is huge but tiny, with a diameter of 109 times the size of the Earth. The Sun makes a really big sphere. You could fit 1.3 million Earths inside the Sun, or you could flatten out 11,990 Earths to cover the surface of the Sun. That's big, but there are some much bigger stars out there. For example, the biggest star that we know of would almost reach Saturn if it were placed inside the solar system. The distance from the Sun to Earth changes throughout the year because the Earth travels on an elliptical orbit around the Sun. The distance between the two bodies varies from surface of the Sun reaches temperatures of 6,000 Kelvin, but this is actually much less than the Sun's atmosphere. Above the surface of the Sun is a region of the atmosphere called the chromosphere, where temperatures can reach 100,000 Kelvin. But that's nothing. There's even more distant region called the corona, which extends to a volume even larger than the Sun itself. Temperatures in the corona can reach 1,000,000 Kelvin. Temperatures inside the Sun can reach 15 million degrees Celsius. At the Sun's core, energy is generated by nuclear fusion as hydrogen converts to helium. Because hot objects generally expand, the Sun would explode like a bomb if it weren't for its enormous gravitational force. The Sun is pretty bright. We know of some amazingly large and bright stars, but they're incredibly far away. Our own Sun is a relatively bright star. If you could take the 50 closest stars within 17 light years of the Earth, the Sun would be the fourth brightest star in absolute terms. Not bad at all. The light from the Sun takes 8 minutes to reach Earth, with a mean average distance of 150 million kilometers from Earth, and with light travelling at 300,000 kilometers per second. Dividing one by the other gives us an approximate time of 520 seconds, or 8 minutes and 20 seconds. Although this energy reaches Earth in a few minutes, it will already have taken millions of years to travel from the Sun's core to its surface. The Sun has a very strong magnetic field. Solar flares occur when magnetic energy is released by the Sun during magnetic storms, which we see as sunspots. In sunspots, the magnetic lines are twisted and they spin much like a tornado would on Earth. The Sun generates solar wind. This is a stream of charged particles which travels through the solar system at approximately 450 kilometers per second. Solar wind occurs where the magnetic field of the Sun extends into space instead of following its surface. The Sun is an almost perfect sphere. There is only a 10-kilometer difference in its polar diameter Astronomers think that the Sun and the planets formed from a solar nebula about 4.59 billion years ago. The Sun is in the main sequence stage right now as a yellow dwarf star, having burned off about half of its store of hydrogen fuel. Eventually, the Sun will destroy all life on Earth and consume the Earth itself. It feels like the Sun has been around forever, unchanging, but that's not true. The Sun is actually slowly heating up. It's becoming 10% more luminous every billion years. In fact, within just a billion years, the heat from the Sun will be so intense that liquid water won't exist on the surface of the Earth. Life on Earth as we know it will be gone forever. Bacteria might still survive or live underground, but the surface of the planet will soon be scorched and uninhabited. This is because when all the hydrogen has been burned, the Sun will continue to burn for about 130 million more years, burning helium, during which time it will expand. Ultimately, after another 7 billion years, the Sun will reach its red giant phase and engulf the Earth, destroying the planet. The Sun will one day be about the size of the Earth. After its red giant phase, the Sun will collapse, retaining its enormous mass, but containing the approximate volume of our planet. When this happens, it will be called a white dwarf. There are spacecraft observing the Sun right now. The most famous spacecraft sent to observe the Sun is the Solar and Heliospheric Observatory, built by NASA and ESA and launched in December 1995. SOHO has been continuously observing the Sun since then and sent back countless images. A more recent mission is NASA's Stereo spacecraft. This was